How does a simple idea become a successful real-world product? It may appear that we start with an idea, design it, manufacture it, and finally put the product into the hands of the customer. But successful product development rarely follows such a straight line. And importantly, the journey should not really begin with an idea. It should begin with a need. From that need, we enter the thinking stage, where we understand the problem and explore possible solutions. We then move into engineering, where the selected concept is analyzed, developed, tested, and improved. Finally, we move into manufacturing, where the design must become something that can be produced reliably and economically. Throughout this journey, we repeatedly explore, create, evaluate, learn, and improve. That is why we call it a spiral. In this module, we will follow this journey, from a real need to a successful product.
Every successful product should begin with a need, not with a solution. A need exists because there is a gap between the current situation and a better situation that people would like to achieve. Consider our washing machine example. The original need was not, "we need a washing machine." The need was much more fundamental. People needed a better way to clean clothes, with less physical effort, less time, and eventually with better use of water and energy. A washing machine is only one possible solution to that need. This distinction is extremely important. If we begin with a particular solution, we may restrict our thinking before we have properly understood the problem. Instead, we should first understand the users, their environment, their difficulties, and what a successful outcome should look like. Only then should we begin exploring possible solutions. So, the first principle of our spiral journey is simple. Start with the need, not with the product.
An idea is an important beginning, but an idea is not yet a product. When we first think of a solution, many things are still unknown. Will it actually solve the user's problem? Will it perform as expected? Can we manufacture it? Will it be reliable? And can we produce it at a price the customer is willing to pay? Consider our washing machine example. We may have an idea for a new washing mechanism. It may look promising, but at this stage it is still based on assumptions. Those assumptions must be challenged and tested. This is an important engineering mindset. Do not become emotionally attached to your first idea. Treat the idea as a possible solution that must earn its way forward through evidence. The journey from idea to product is therefore a journey of progressively replacing assumptions with knowledge. And that is exactly what the TEM Design Spiral helps us to do.
The journey begins at the bottom of the spiral, with thinking. And good engineering begins with understanding, not with building. First, we need to understand the users. Who are they? What are they trying to achieve? What problems do they currently face? From this understanding, we define the requirements. What must our product actually do? And what would simply be nice to have? We must also identify the constraints: cost, size, energy consumption, safety, regulations, available technology, and the environment in which the product will operate. Only then should we begin exploring possible solutions. For our washing machine, there may be many different ways of satisfying the same basic need. We explore these alternatives, compare their advantages and limitations, and select the most promising concept. This is why thinking is not simply having an idea. It is a disciplined engineering activity. The better we think at the bottom of the spiral, the fewer problems we are likely to face at the top.
Even within the thinking stage, we should not move directly from a problem to a single solution. We begin by exploring. For our washing machine, we might consider many different approaches: improving hand washing, using twin tubs, agitators, rotating drums, compact machines, or even completely new mechanisms. Then we create. We turn promising ideas into something that we can examine: a sketch, a simple model, a CAD concept, or perhaps a very basic prototype. Then we evaluate. Does it clean effectively? How much water and energy might it use? Is it safe? Is it affordable? And will people actually want to use it? Evaluation gives us new information, so we go back, explore again, modify the concept, and evaluate again. This is the first loop of the TEM Design Spiral. The objective is not to prove that our first idea was correct. The objective is to learn enough to select a concept worth engineering. Once we have selected a promising concept, we move upward in the spiral into the engineering stage. Now, our question changes. We are no longer asking only, is this a good idea? We begin asking, can we make this idea actually work? For our washing machine, we define the system architecture, the washing mechanism, drive system, water system, control system, and mechanical structure. Then engineering principles come into play. We calculate the required motor torque and power. We analyze the drum dynamics, structural loads, water and energy consumption, component life, safety, and reliability. We develop CAD models, perform simulations, select motors, bearings, pumps, sensors, electronics, and suitable materials. And importantly, we continue to explore, create, and evaluate. Engineering is therefore not simply converting a sketch into a detailed CAD model. It is the process of progressively replacing uncertainty with analysis, evidence, and validated engineering decisions. By the end of this stage, we should have much greater confidence that our proposed product can actually perform as expected in the real world. Once we have an engineered design that performs as expected, we move further up the spiral into manufacturing. But having a working design does not automatically mean that we have a successful product. Now we must ask a different question. Can we manufacture this product repeatedly, reliably, and at an acceptable cost? For our washing machine, we examine every part from a manufacturing perspective. Can we simplify the components? Can we reduce the number of parts? Is the product easy to assemble and test? What tooling, equipment, and production processes will we need? We must also establish suppliers, quality control methods, work instructions, and testing procedures. Then we build a small pilot batch. This is extremely important because manufacturing several units often reveals problems that were never visible in a single prototype. We learn from those problems, modify the design or process, and repeat. So manufacturing is not simply about making the product. It is about learning how to make it consistently, efficiently, reliably, and economically at scale. That is how an engineered design becomes a real product. Now we come to the most important reason we represent this journey as a spiral rather than a straight line. As we move forward, we continuously discover new information. For example, during engineering, our simulation may show that the washing machine vibrates excessively. That may force us to go back to the thinking stage and reconsider the basic mechanism. Later, during pilot manufacturing, we may discover that a component is difficult or expensive to assemble. We may then return to engineering and simplify the design. And even after the product reaches customers, feedback may reveal something that we did not anticipate. So moving backward in the process does not necessarily mean that the project has failed. It means we have learned something. We use that new knowledge to improve the product and then move forward again. Each loop should reduce uncertainty, improve quality, and increase our confidence in the solution. That is the fundamental idea behind the TEM Design Spiral. Explore, create, evaluate, learn, improve, and repeat. The objective is not perfection in the first pass. The objective is progress through disciplined learning. After all these stages and iterations, what is the final objective? It is not simply to complete the design, and it is not simply to manufacture something. The objective is to create a better product for real people. For our washing machine, success means much more than making the drum rotate and the clothes become clean. The product should be safe and reliable. It should be easy to use. It should consume reasonable amounts of water and energy. It should be affordable to the intended customer, and it should be possible to manufacture consistently at the required quality and cost. That is why the journey begins with understanding people and ultimately returns to people. Once customers begin using the product, we learn again. Their experience gives us new information that can lead to improvements, new versions, or even completely new solutions. So reaching the market does not necessarily mean the spiral has ended. A successful product is not simply something that works. It is something that creates real and lasting value. Now we can bring the complete journey together.
We begin with a need, not simply with a product idea. During thinking, we understand that need, explore different solutions, create concepts, and evaluate them until we identify a promising direction. Then we move upward into engineering. Here, calculations, analysis, simulation, detailed design, component selection, and testing progressively turn the concept into a solution that should work reliably in the real world. Next comes manufacturing. Now we must make sure that the product can be produced consistently, efficiently, at the required quality, and at an acceptable cost. But notice what happens throughout the entire journey. At every level, we continue to explore, create, and evaluate. When we discover something new, we may loop back, learn, modify the design, and move forward again. And even when the product reaches the customer, the learning does not stop. So the TEM Design Spiral is more than a sequence of development stages. It represents an engineering mindset. Think early, test early, learn early, improve continuously. That is how a need becomes an idea, and an idea becomes a product that creates real value.
Now, the important question is, how do you apply this to your own engineering projects? Whatever you are developing, a robot, an electronic device, a machine, a software system, or even a student project, the basic discipline remains the same. Start by defining the real need. Then explore several possible solutions before committing to one. Create something that helps you learn: a sketch, calculation, simulation, model, or prototype, and evaluate it using evidence. Once you have a promising concept, engineer it properly. Analyze it, calculate, simulate, select appropriate components, and validate its performance. Then consider how it will actually be manufactured, assembled, tested, and delivered consistently. And when the product reaches the real world, keep learning. Listen to users, measure performance, identify weaknesses, and begin the next improvement loop. So do not treat the TEM Design Spiral as just a diagram from this course. Use it as a practical way of thinking about every engineering project. Good engineering is not luck. It is a disciplined and repeatable process.
As we conclude this module, there is one idea I would like you to remember. Engineering is not simply about creating things. It is about solving real problems, learning continuously, and creating value for people. We begin by understanding the need. We think broadly, question assumptions, and explore alternatives. Then we engineer with discipline, using calculations, analysis, simulation, prototyping, testing, and evidence. We design for manufacturing so that our solution can be produced reliably, safely, consistently, and at the right cost. And when the product reaches the real world, we continue to listen and learn. Because the spiral does not really end. Every product, every test, every failure, and every customer experience can teach us something that makes the next solution better. So the TEM Design Spiral is not just a product development process. It is a way of thinking and working as an engineer. Think early, test early, learn early, improve continuously. And above all, design better. Build what matters.